Hello, students. This question is really a good question to test your concepts. This is not a formula based question. And if your concept is good, you will be able to solve it. Otherwise, this looks like easy problem, but it's very difficult to get the correct answer. Okay. So this is a core conceptual problem in the sense those students whose concepts are very clear, they can only solve this question. Those students who just mug up the formulas, for them, you will find it difficult. Okay, so let's read the question and let's try to understand and let's check if your concepts are clear or not. In the circuit shown, switch S2 is open and S1 is closed since long time. Okay, S2 is open and S1 is closed since long time. All right, take E is equal to 20 volt. So this is 20 volt. 3E will become, this is 60 volt. L is equal to 0.5 Henry and R is equal to 10 ohm. So this is 10 ohm. 2R will be 20 ohm. The magnitude of rate of change of energy stored in the magnetic field inside the inductor immediately after S2 is closed and S1 is also closed, okay, is 5 n joules per second. Then we have to find the value of n. So we have to find, the first thing that I will read is find the rate of change of energy stored in the magnetic field inside the inductor immediately after S2 is closed. So first thing that would come to my mind is energy is equal to half Li square, and rate of change of energy with respect to time will be half L. I square differentiation will be 2I into di by dt. So 2 will get cancelled. So du by dt is equal to Li di by dt. So this is what we have to find technically. This I will do it first. Then I will check what will happen when S2 is just closed. So before S2 is closed, what is the case? When S2 is open, only S1 is closed for a long time. S1 is closed since long time. So that means inductor must have become fully charged and current must be maximum. So in that case, this is 2 volt, sorry, 20 volt, this is 10 ohm. So maximum current would be V by R. I is equal to, so maximum current would have become V by R. So V is equal to 20, R is equal to 10. So this would have become 2 ampere, right? Inductor is behaving like a short wire. So 2 ampere current is flowing like this initially. So this is the concept that everyone knows probably. At time infinity, when it is fully charged, the inductor behaves like a short wire. So current is equal to V by R. Now the concept number 2, which is being checked. So this is your, let's say, this was my step 1. Looking at what we have to find. This is your step 2, starting the analysis. Now step 3, this is a good concept. Let's see how many of you know this concept. Whenever you suddenly change the circuit, suddenly switch on or switch off, whatever, the flux inside inductor does not change immediately. And if there is only one inductor, so if flux does not change immediately, then flux is equal to Li. So that means I also does not change immediately. So just remember it, whenever you suddenly change something, then suddenly there will not be any change in the inductor. Flux will remain same, therefore flux is equal to Li. So current will also remain same. So when S2 is just closed, so this will be the situation. I will draw the diagram. Just let me know if you understand this. So this is the inductor. Everything is as it is. Now S2 is also closed. This is 20 ohm. This is 60 volt. This is 20 volt. L is there. Okay. So now this is just S2 is closed. Okay. Just it switched on. So now you see what's happened when it is just closed. The current in the resistor can change immediately if needed, but current in the inductor will not change suddenly. So that means this inductor will still have 2 ampere current, but this side in the 10 ohm resistor, earlier current was 2 ampere, but as soon as you switch on S2, the current in the inductor will remain 2 ampere, but this current will change immediately. So let's say this is I1 and let's say here current is going as I2. So this is the diagram, just S2 is closed. So this is the interesting part, when just S2 is closed. So this is the concept number 2 that you have to study. Okay. So this is your step 3 or concept number 2. The concept is suddenly the current through inductor will not change. Current through resistance may change, might not change depending on the situation. So in the inductor current will be 2 ampere, but in 10 ohm, immediately from 2 ampere it will become I1, and in the next part, let's say current is I2. Now the step 4, the calculation part. So in step 4, you can use KVL in the bigger loop. Let's say I am using the KVL in the bigger loop. So 20 minus I1 into R, then plus 60, then minus I2 into R is equal to 0. I have used KVL in the bigger loop. Now I1 is equal to I2 plus 2 ampere, right? I1 is equal to 2 plus I2. So I1 we can write 2 plus I2. So this 20 plus 60 will become 80. So 80 is equal to 20 I2 plus 10 I1. So plus 10, and I1 is 2 plus I2. So what will be the result? This is 60, and 20 I2 plus 10 I2 is 30 I2. So 60 is equal to 30 I2. Therefore, I2 is equal to 2 ampere. So that means when you suddenly switch on S2, the current in that part will be 2 ampere. I1 is 2 plus I2. So I1 will become 4 ampere. So suddenly the current in 10 ohm resistor changes. So this is a unique and interesting thing. So now when you have I2 is equal to 2 ampere, then we can just get the result. Just a sec. Okay. Then you can just get the result in step 4, in step 5. Now we have to find this. We already know we have to find this, right? So how to find this? Just use the expression. In the right part of the circuit, let's again apply KVL. So 60 minus current is 2 ampere. We have just calculated current is 2 ampere. So 260 minus 2 into R is 20 minus L di by dt is equal to 0, right? 60 in the right part of the circuit. Okay, I am using in the right part of the circuit. So 60 minus IR minus LDI by dt is 0. That means 60 minus 40 is 20, right? 60 minus is 20. So LDI by dt is equal to 20. And we have to find du by dt, which is Li into di by dt. So LDI by dt is equal to 20. Therefore, L di by dt multiplied by I will be 20. And what is the current that is flowing? The current that is flowing here is 2 ampere. Current that is flowing in the inductor is 2 ampere. So that means answer will be into 2. So this is 40. So rate of change of energy with respect to time is 40, and it is given 5n. So that means 5n is equal to 40. Therefore, the value of n is 8. So see, this is a really good problem to just check all your concepts regarding this inductor circuits and all. So this is not a formula based question, and the concept number 2 was very important, that current through resistor can change immediately, but current through inductor will not change immediately. So using that fact, we found the new current and then we got our answer. So just revise this problem again if you want to make your concept strong. All the best and bye bye.